Here's a good related rates problem. I'm going to kind of go back to my strategies, and first I'm going to try and understand the problem. I kind of like to do that as I diagram it out, which is developing a mathematical model of the problem. So let's start with that. So a 5-foot tall person is walking away from a 17-foot tall lamppost at a rate of 2/x feet per second, where x is the distance from the person to the lamppost. Well, that's a lot of words right there. So let's start drawing a picture. Here is my lamppost, and here's light coming off of the lamppost. And I know that that's 17 feet high. And here is my person walking away from it. Tall person, long legs. Okay? And I know that that person is 5 feet high. And this person is walking away from the lamppost, so they're walking in this direction. Oh, that made it look good. At a rate of 2 divided by x feet per second. Well, that's interesting. Where x is the distance from the person to the lamppost. So this distance right here from the person to the lamppost, that distance is x. Assume the scenario can be modeled with right triangles. Okay. What is the length of the person's shadow changing right at this point when the person is 17 feet from the lamppost? Well, let's look at the shadow. The lamp light is coming off the lamppost. It's hitting the person. And so the person's shadow would be this distance right here. And let's call that S. So what do I seek? And what do I know? Well, I am seeking the change in the length of his shadow as he walks away from the lamppost. So what I am seeking is ds dt. Well, what do I know? Well, I know I know that the lamp, so let's call this h, that's the height of the lamppost. So I know that h is equal to 17, and I know that that is constant. That is not going to change at all. So I put little brackets around it. And I know that the person's height, we'll call that p, is equal to 5. And I also know that that's not going to change. His height's going to stay the same. I also know that he is walking away from the lamppost, so the change in x over the change in time is equal to 2 divided by x. So those are the things I know, and I'm seeking ds dt. Now, can I develop a mathematical model relating these variables, what I seek and what I know? So I know the rate of change of x right here, and I'm seeking the rate of change of s. Well, I do have these two similar triangles. So I know that x plus s, that's the base of this big long triangle here, is to 17, which is the height right here, as s, which is the base of this little triangle right here, is to 5. Well, I think that just made me very happy, because I think that's the equation that I need. So I'm going to do some cross multiplication here. So I'm going to get 5x plus 5s is equal to 17s. I just cross multiplied. So I'll subtract 5s from both sides, and I get 5x is equal to 12s. Well, this is going to be really simple. So I'm going to take, I know what dx dt is. So I think what I'm going to do is I'm going to make my life just a little bit easier since I'm seeking ds dt. I'm just going to get my s all by itself. So I'm going to divide both sides by 12. So I know that s is equal to 5/12 x. Well, how about I take the derivative with respect to time of s and the derivative with respect to time of this formula, this expression right there. So I have the derivative of s with respect to time is equal to 5/12, pulling the constant through the derivative, dx dt. Well, I know dx dt. dx dt is 2 over x. So I know that I have 5/12 times 2 over x, and I'm looking for it, as it says in the problem. I want to know when the person is 17 feet from the lamppost. So I know what x is, so I can go is equal to 5/12 times 2 over 17, which is equal to 10 divided by 204, or I can simplify that as 5 over, come on, I can divide this by 2, 102 feet per second. That is ds dt. Tricky part of this problem here was basically just kind of recognizing what the that I have these similar triangles and the similar ratios. Because once I got the ratios, which really weren't that complicated, the math on this problem is really pretty straightforward.